Hello again. Today we are talking about rational functions, day one. We'll be having another lecture on this again the next time, but today our basic idea is that we're going to be talking about vertical and horizontal asymptotes and graphs. Now, I'm going to be assuming that you are graphing these functions as we go along, just like we would have had been teaching in class. I won't be waiting for that, so you'll probably have to pause so that you can get the graph, but I will be going on the assumption that you will be doing it with a table and not copying off of the graphing calculator, because this next section will be on your next quiz and it will not have a graphing calculator on that particular part. So here we go. Rational functions, day one. We're going to talk about vertical and horizontal asymptotes. Vertical asymptotes are asymptotes that are vertical, and horizontal asymptotes are asymptotes that are horizontal. Remember, an asymptote is a line the graph gets really close to, but never ever crosses it. It's a boundary line. So a vertical asymptote is going to occur wherever the denominator equals 0. So if I look at this equation here, I have x plus 2. I know that at -2, I will have an asymptote because that's where the denominator equals 0. Notice that it's an x equals line because it's vertical. So there's my line, x equals -2, and my graph goes and approaches it and gets really close up here, but it will never ever cross it. It will approach it on both sides in this particular case. We'll talk about how you can figure that out in a couple of slides down the line. If I have a horizontal asymptote is found when there's an exponent in the top and an exponent in the bottom, and they're the same thing. When that happens, you're going to take the leading coefficient of the top and the leading coefficient of the bottom, and then 6 over 1 in this case would just be 6. So then, since it's a horizontal asymptote, I know it's going to be the equation y equals 6. So that means my graph will be really close to the line y equals 6, but will never touch it. And it gets really close, and it looks like it touches it, but actually it doesn't. So those are horizontal and vertical asymptotes. This kind of basically explains that, but in lots of math talk. So here's my function. My function is a of x over b of x. Notice that a is on the top and b is on the bottom. They're both simplified. They have no common factors other than 1 or -1. When I have a vertical asymptote, the vertical asymptote is where I have real zeros of b of x. In other words, the zeros of the denominator. When I have a horizontal asymptote, as I just said, that's going to be a little bit different, a little more in depth than what I just said. So notice that I have n is less than m. N is less than m means the degree of the top is smaller than the degree of the bottom. When the top is smaller than the bottom, then y equals 0 is the equation of my asymptote. If the two of them are equal, like I said on the previous slide, then that's when you take the leading coefficient of the top divided by the leading coefficient of the bottom, and that's y equals for that, for my horizontal asymptote. And then if I have the top bigger than the bottom, then that means there is no horizontal asymptote. So you kind of have to figure that out. If the top is bigger than the bottom, then it's y equals 0. If they're equal, then it's the leading coefficient of the top and the bottom. And if the top is bigger than the bottom, there is no vertical asymptote. In order to find my intercepts of my graph, the x-intercepts occur wherever the top equals 0. Top is a of x. Then the y-intercepts will occur when you put a 0 in for x and you solve for y. That hasn't changed from what we've done in algebra before. So if I have the vertical asymptotes, the horizontal asymptotes, and then the x and y intercepts, that's going to help me to graph my equation. The rest of it will be done by using a table. So here's our first problem. I have y equals, or k of x equals, 7 over x plus 5. So the first thing I'm going to figure out is I'm going to figure out the domain. So I would find the domain by looking at the denominator. I can see that I would have something that would be undefined at -5. So that means my graph is all reals except when x equals -5. And that's kind of what that says right there. After that, I would figure out my asymptotes. The horizontal asymptote, I would take the degree of the top over the degree of the bottom. But if I look, the degree of the top is 0 and the degree of the bottom is 1. So I have something that is the top is bigger than the bottom. Sorry, the top is smaller than the bottom. So when the top is smaller than the bottom, that means my horizontal asymptote is y equals 0. Then I need to figure out my vertical asymptote. My vertical asymptote I find by doing the denominator equal to 0, which would be x equals -5. So my horizontal asymptote is y equals 0, and my vertical asymptote is x equals -5. I would suggest you copying down the equation because I didn't put it on the next slide. So I have k of x equals 7 over x plus 5. And then that's what I just said about the vertical asymptote being at x equals -5. And since the top is smaller than the bottom, that means y equals 0 is my horizontal asymptote. The next thing I would have to find are my x and y intercepts. If I have put a 0 in for x, I would end up with 7 over 5. So 7 over 5 is 1.4. So that means my y-intercept is going to be at 0, 1.4. And then to find the x-intercepts, I would set the numerator equal to 0. But when I do that, I get 7 equals 0. So that just means there are no x-intercepts. And that would make sense because I already know that my y equals 0, which is basically the x-axis, is going to be my horizontal asymptote. So that means the graph can't touch it there. From there, I would just have to now make a table to put the rest of the points in. So there's the information about my intercepts. And then I would need to graph the intercepts and my asymptotes and then make a table. So the basic part of the graph, the asymptote sort of divides the graph into two sections. One section is smaller than the asymptote, and the other section is greater than the asymptote. So if it's smaller than the asymptote, that would be between -infinity and -5. So you kind of want to pick a couple points that are in there and stick them into the equation to find out what points you would get so you could graph it so you get kind of an idea of what's happening as it gets close to the asymptote coming from the left. Then you would need to put some points into the equation in the interval between -5 and +infinity to see what happens to the right of the asymptote. So you can pick kind of whatever points you want. You can see I picked a couple of them, but you can pick whichever ones make you happy as long as you have some that are on the left of the asymptote and some that are on the right of the asymptote. And you can get an idea of what's happening with the curve. It's got to be smooth. It can't be jagged because this is a graph that should be smooth as opposed to something that is linear or just a scatter plot. So if I were to graph it, it would look just like that. Notice that there's my my vertical asymptote at x equals -5. I have another one you really can't see very much because it's not there, is the line y equals 0. I know my intercept is 0, up here, 0, 1.4. And then you can see the other points that I just kind of graphed in there so that it could be connected and see what happens as x approaches the axis. I'm coming from the left and coming from the right. So then our next problem would look like this. This one has a little bit more to do with it because now I have something that I could possibly cancel out. So our first step would be to factor whatever I can. So I could factor the bottom into x plus 2 and x minus 2. When I do that though, I can't cancel anything out, so that means I'm just left with that equation. So then if I were to come up with my domain would be restricted wherever the denominator equals 0. So it's restricted at +2 and at -2. So that means my domain is the reals, except where x equals 2 and x equals -2. Once I have my domain, then the next thing we need to figure out is my asymptotes. I would have a vertical asymptote wherever the denominator equals 0, so x equals 2 and x equals -2. And I would have a horizontal asymptote. When I look to this part, it's probably easier to look back at the original. I guess you could use the factored form, but I like to look at the original because I can see from that has a degree of 1, that has a degree of 2. So that tells me that the top is smaller than the bottom. So since the top is smaller than the bottom, I know that I am going to have a horizontal asymptote at y equals 0 again. And then I would need to figure out my intercepts. My x-intercept I'm going to find by solving the numerator for 0. So if I solve the numerator for 0, I would have -1. So that means I would have the point at -1, 0. And if I were to find out where my, brain freezer, my y-intercept, it would be at -1/4. So that would be at -1/4, 0. So then I would take all of those points and put the rest of them to graph what I have and put the rest of them into a table. So again, copy the equation down because on the next couple slides, I'll show you everything of what I just said, but I didn't copy the equation down. So there's the information. We said that that was our factored form, and I can't cancel anything out, so that's the expression in simplest form. I know that it's going to be undefined, so there's going to be my domain, where x is the reals, but x can't equal 2 or -2. I know I have vertical asymptotes at x equals 2 and x equals -2, and a horizontal asymptote at y equals 0. And then I would graph all of that information, and there is my graph. I have my my asymptote at y equals 0. I have my asymptote at x equals 2 and x equals -2. I have my y-intercept at y equals y at 0, -1/4. I have my x-intercept at -1, 0. And then, of course, I haven't shown you the table, but I made a table so that I could see that the graph is going down down here. It's going up here and down here and over there. Oh, and going up there. So again, that's all found by using a table and taking information from the interval between -∞ and -2, between -2 and +2, and between +2 and +∞. For the next equation, again, first step would be to factor. So if I factor the top and I factor the bottom, I would be left with that equation. Again, nothing cancels out. So that's the equation in simplest form. So I would need to find my domain. My domain will be the reals, except where x equals 2 and x equals -2. My vertical asymptotes will be where x equals -2 and x equals +2. My horizontal asymptotes, again, if I go back to the original, they both have the same degree in the numerator and the denominator, x squared and 2x squared. So that means y equals 1/2, because I take the leading coefficient of the top and the leading coefficient of the bottom. So that's y equals 1/2 will be my horizontal asymptote. I will get my x-intercepts by setting the numerator equal to 0. So my numerator is equal to 0 at -3 and +4. And my y-intercepts will be at +12/8, which is 1.5. So here's all that information. Hopefully you've copied down the equation already. So there's my domain. As I said, it's the reals, except x cannot equal -2. There are my vertical asymptotes at -2 and +2. There's my horizontal at y equals 1/2. And my x-intercepts from setting the numerator equal to 0 at 3 and 4. And the y-intercept is when I put a 0 in for x and solve for y, I get 12/8, which is 1.5. I'm going to take all of that information and put it onto my graph. So when I put it onto my graph, it looks like that. And again, now I have some other intervals, and I'm going to plot points in those intervals between -∞ and -3, between -3 and -2, between -2 and 2, +2, and between 2 and 4 and infinity. And once I do put all those different intervals and I've plotted the points, which does take a good deal of time, yes, I know, you will get that graph that looks like the blue, and the dotted red ones are your asymptotes. So that's the basic lesson for today. We'll have more practice when I see you in class the next time. The next lesson will basically be the same idea, except then we'll be talking about oblique asymptotes or slanted asymptotes, which are a little bit more tricky, but really not that much. So we'll also review how to solve equations with fractions in them, which should be a review of the stuff that we did last year. Hopefully you have a good time. I'll see you then. Bye.